Hi everyone, this is Sir Amboy once again and welcome back to my YouTube channel. So, in the previous topic, we have learned how to formulate differential equations from a given solution. And that is through the elimination of the arbitrary constants or parameters. And you may recall that the general solution of an ordinary differential equation represents a family of curves. And now, in this episode, our goal is to obtain the differential equation that describes a given family of curves. So now, I will explain to you how this process is done. First, a family of curves will be given as a problem. So we have a family of curves. So usually, the family of curves will be described in words. And after that, we will formulate a mathematical expression. It could be a function, or if not a function, strictly speaking, it could be a relation that describes this family of curves. So, this function or relation that we will formulate describing this family of curves, this is actually the general solution of the ordinary differential equation that we are looking for. So now that we have the general solution in the form of this function, the next step is to eliminate the arbitrary constants or the parameters. Okay, so after we have eliminated all the parameters, then what will be left is the desired differential equation. So, to demonstrate to you how this is done, let us solve the first example. So, the first example involves a family of lines. So, here's the problem. Find the differential equation of the family of lines passing through the origin. Before we solve the problem, it would be better if we can visualize the family of lines. So, how do these lines look like? All of them would be passing through the origin. So these are this is the family of lines. So if you notice, all lines passed through the origin. Now, what do you think would be the best equation of the line to represent this family of lines? There are several equations that we can use, but the most practical thing to use is the one which contains the least number of arbitrary constants, and that would be the slope-intercept form of the line. If you recall, the slope-intercept form can be written as y equals mx plus b, where m is our slope and b is our y-intercept. Okay, but in the problem, it is said that all the lines passed through the origin. So that means that the y-intercept b is now equal to 0. And because b is equal to 0, then it will vanish from our equation. And we will be left with a single arbitrary constant, which is the slope. Okay, now if we look at this family of lines, we know that this slope may vary because for every line here, we have a different slope. For example, the slope of this green line is different from the slope of the white line, and the slope of this orange line is different from the slope of these other two. So all the lines in this family of curves have a unique slope. Okay, that is why m is an arbitrary constant here. This is our parameter. And since we only have one parameter, how many derivatives are we going to take? We need to differentiate this only once to eliminate the arbitrary constant m. So if I differentiate y, I will get y prime, and the derivative of mx with respect to x, of course, is m. Okay, so I am now having a term containing the derivative here. And remember, we are looking for a differential equation, but a differential equation must not have any arbitrary constant. So we need to eliminate m. And how are we going to eliminate m? Okay, from this expression, from y is equal to mx, we can actually solve for m. Here, m equals y over x. And we can use this m and substitute it in our equation for y prime. Okay? So using the substitution method, this time, m equals y over x. So if I multiply both sides by x, I will get x, y prime equals y. So this is now my differential equation. I can equate it to 0 by writing it as x, y prime minus y equals 0. So this could be my final answer. So here, we have an explicit derivative, y prime. If you want, you can also write your answer in the differential form by multiplying both sides of the equation by dx. So if we multiply both sides of the equation by dx, what will be left here is just the numerator dy, and y would have a multiplier dx. So I write the answer in differential form, x dy minus y dx equals 0. So again, this could also be your final answer, and this could also be your final answer. This is in the derivative form because we have an explicit derivative, and this is the final answer written in terms of the differential form. So that's it. Madali lang, di ba? Okay, so let me repeat the process. After having the family of curves given in the problem, the first step is you need to formulate a function or a relation that describes the given family of curves. Now, that function represents the general solution of the differential equation that we are looking for. So the next step is to eliminate the arbitrary constant. So we can do that by means of elimination method, just like what we did in the elimination of arbitrary constants, or here, what I did is using substitution. Now that I have eliminated the arbitrary constant, I am left with the differential equation that is desired. So this is now the differential equation that describes the family of lines passing through the origin. Okay? So I hope that's clear. Now we can proceed to the next example. So in the next example, we have a family of parabolas. Okay, let us take a look at the problem. Find the differential equation of the family of parabolas. So this time, parabola naman ang given. Ang mga parabola daw na ito ay may vertex at the origin and their foci are on the y-axis. Okay, so can we visualize how these parabolas look like? Okay, so it's said that the vertices of all the parabolas are at the origin, and their foci are on the y-axis. So, can you imagine if all the foci of the parabolas are on the y-axis, then it means that the axis of the parabola is the y-axis itself. Meaning, these parabolas have a vertical axis. Okay? And if they have a vertical axis, there are only two possible things. So the parabolas must be opening, it's either upward or these parabolas must be opening downward. Okay, so this is how the parabolas look like. So if their vertices are on the origin and their foci are on the y-axis, so they must have a vertical axis, and their axis is actually the y-axis. That is why the parabolas are opening upward or they can be opening downward. So these are just some of the members of this family. Now, what equation best describes these parabolas? Okay, so now we may need to recall the equation of a parabola. So the equation that we will be using is the standard form of the parabola. So if we recall that for parabolas having vertical axis, the standard form is given by x minus h squared equals 4a times y minus k. So, kinakailangan po alam natin ang formula na ito. Again, this is the standard form or equation of parabolas having vertical axis. Okay. So, in this equation, we have how many parameters? H, A, and K. So, we have 3. However, we can actually reduce the number of parameters by following the problem. It is said that the vertices of all the parabolas are at the origin. Here, H and K are the coordinates of our vertex. So that means that if the vertices are at the origin, h is equal to 0 and k is also equal to 0. So we can simplify our equation by making h and k equal to 0. So now, our equation will be x squared equals 4a times y, because h and k are already 0. Again, I'd like to repeat. Why are h and k equal to 0? Because in the problem, it is stated that the vertex of all these parabolas are at the origin. And if you are at the origin, of course, the coordinate of h and k are both 0. Okay? So now we are left with a single parameter, a na lang. But 4a is a constant. In order to further simplify this, gawin ko na lang yung 4a na isang constant na arbitrary, x squared equals ky. So now we have a single arbitrary constant k which needs to be eliminated so we can form its differential equation. And how are we going to do that? We need to differentiate this expression with respect to x. Okay? So that is the next step, to differentiate the equation representing the parabola so we can obtain its differential equation. Okay? So now let's differentiate with respect to x. So, the derivative of x squared, of course, is 2x, and that is equal to k times y. So, k is a constant, and what is the derivative of y with respect to x? It's just y prime. Okay? So, this is now our differential equation, but the differential equation contains the arbitrary constant k, which must be eliminated. Okay? So, just like what I did earlier in the previous problem, I can solve the value or the expression for k here. So, here, k equals x squared over y. And I can use this k or substitute this expression here so I can eliminate k. So now I have 2x equals k, which is x squared over y, and then multiply that by y prime. Now, to write this in a simpler form, let us eliminate the denominator by multiplying both sides by y. Okay, multiplying both sides by y, we will get 2xy equals x squared y prime. And here, we notice that x is a common factor. So we can divide both sides of the equation by x, and what will be left is 2y equals xy prime. So this is now my differential equation. Tapos na ang laban. Ano? Kung gusto mo, i-equate mo yan sa 0. Equate natin sa 0. xy prime minus 2y equals 0. So this could be your final answer, again in derivative form, because we have the derivative explicitly written as y prime. But if you want, you can also express your answer in the differential form by multiplying both sides of the equation by dx. So in its differential form, the differential equation would be x dy minus 2y dx equals 0. So this could be my final answer, or this could be my final answer. So both are differential equations that describe a family of parabolas whose vertices are at the origin and whose axes are vertical. Okay? Di ba madali lang? Sobrang dali. Kayang-kaya niya yan. At dahil dyan, let us solve another example. This time, let us have a family of circles. Oh, by the way, I forgot to tell you. Sir, what if ang parabola ko pala ay opening to the right or to the left? Ayan. Okay? So, ihahabol ko lang ha. If ever the parabola is opening to the right or to the left, that means horizontal ang axis niya. Sulat natin dito. Parabolas with horizontal axis. Ano ang kanyang standard equation? So we have y minus k squared equals 4a times x minus h. Yan naman ang gagamitin mo if ever ang given parabola ay horizontal ang axis. Tapos, kapag may given vertex, papalitan mo lang yung h at saka k. And kagaya nung ginawa ko kanina, tanggalin mo na yung 4a, gawin mo na lang siyang isang constant para mawala yung 4, isang letter na lang or isang, isang letter, k na lang yung gamitin mo para mas simple. Okay? Sige. Punta na tayo sa third problem. This time, we have a family of circles. So, sabi ng problem, formulate a differential equation describing all the circles whose centers are at the origin. So anong itsura ng mga circle na ito? So mga circle sila. Ang kanila daw, center ay nasa origin. So pwedeng iba-iba ang radius nila basta ang kanilang center ay nasa origin. So ito yung mga yan. Ano? So we can see that all these circles have their centers at the origin, and the thing that varies is their radius. Nagbabago yung radius nila. Okay? So what is the equation that describes a family of circles? What is the standard equation of a circle? Okay, so we write the standard equation of a circle. So if you recall, that's x minus h squared plus y minus k squared equals r squared. So you should remember this, just like the standard equation for the parabolas kanina. Now, since all circles have their centers are at the origin, h and k must be 0. Why? Kasi nga po, ang center nila ay nasa origin. Yung h at k natin ay mag-0. Kaya, ang matitira na lang sa atin is x squared plus y squared equals r squared. Okay, so here we have a single arbitrary constant r which represents the radius of the circle. So after that, kailangan na natin mag-differentiate para ma-eliminate itong arbitrary constant na r. At dahil isa lang ang ating arbitrary constant, isa lang din tayong beses magdi-differentiate. Okay, of course, when we differentiate, that is with respect to x. So let us now differentiate this entire equation with respect to x. So we have 2x plus the derivative of y squared with respect to x is 2y. And using the chain rule, we need to attach y prime equals the derivative of this, which is just a constant, is now 0. Okay, so here we can divide both sides of the equation by 2 and get x plus y prime equals 0. So we now have the differential equation. Ito na yun. Hindi mo na malayan, tapos ka na pala. This is now the differential equation that describes the family of circles whose centers are at the origin. Okay? You may also express this final answer in differential form by multiplying both sides of the equation by dx. We will get x dx plus y dy equals 0. Again, you can express your final answer in this form if it's in the derivative form, or you may express your final answer in the differential form. Sir, kapag exam, ano ang gagamitin ko? Okay, if I am your professor, I will specify kung anong form ang gagamitin mo sa iyong final answer. If you will be expressing it in derivative form, or you will be expressing it in terms of the differential form. Okay? So, di ba ang dali lang? Sobrang dali. Walang kasing dali. Para itong dartboard. Kaloka. So let's proceed to the next example. So this example also involves a family of circles, but unlike the previous one, this is more challenging. Let us take a look. Find the differential equation of all the circles with centers on the line y equals x and passing through the origin. So imagine, lahat daw ng circles, ang kanilang gitna or center ay dumaan sa line na ito. Ano ba ang itsura ng line na y equals x? Di ba kapag ka ikaw ay may y-axis at x-axis? Ito yung line na y equals x. Yan. 45 degrees ang inclination yan. So that means, lahat daw ng circle, ang kanilang center ay nasa line na yan. Tapos, lahat daw sila dadaan sa origin. So kung dadaan sila sa origin, ay di, example, ito yung isa. Or pwedeng ito. Or pwedeng ito. Or pwedeng yun. O, diba? Pero ang pangit ng circle ko, kaya gawa na lang ako ng bago. Ayan. At i-delete na natin yung drawing ko. Okay? Kasi pampasama siya ng view. Ayan. Okay. So this is now the family of circles described in this problem. The next step is to formulate an equation that describes the family of circles. So once again, we will be using the standard equation of a circle. Can you recall the standard equation of a circle? Okay, sabay-sabay tayo. That is x minus h squared plus the quantity y minus k squared equals r squared. Here, again, h and k represents the coordinates of our circle or the center. So, kung itong circle na ito, nasa ang hk niya? Andito. Ito yung center niya. Kung itong circle na ito, which is its center, Okay, ito ang center. This is the center of the second circle. And how about the third circle, the bigger one? This is its center. Okay, so here, initially we have how many parameters? 1, 2, and 3. But we need to impose the condition that the center of all the circles are on this line. So here we have the HK of the first circle. And here we have the HK of the second circle and the third circle. Okay, now, let us consider this largest circle for illustration. And let us see the relationship between H, K, and R. Okay, so we need to establish a relationship between H, K, and R so we can reduce the number of the arbitrary constants. Kasi tatlo yan eh. So kung tatlo yan, baka pwede nating i-reduce into 1 or possibly into 2. Diba? Mas maganda sana kung isa na lang arbitrary constant ang matitira. And we can do that by establishing a relationship between H, K, and R. Okay? So let us use the largest circle whose center is this. So alin ang H niya? Ito yung H niya. Okay? Yan ang H niya. At ito naman ang kanyang K. And ito yung R niya. Definitely, this is its radius. Ayan. Ito yung R niya. So, we have drawn H, K, and R. And obviously, itong H na ito, I can write that H here because this H is also equal to this. So, we now have a right triangle involving K and H as the legs and R as the hypotenuse. Okay? And, of course, since we have a right triangle, we can use the Pythagorean theorem. So, we can relate the three. H squared plus K squared equals R squared. Okay, so let us establish further some relationship. Okay, so if you notice, the value of H and K are the same. Okay, why? Because this line has a slope of 1 because y is equal to x. Yung slope niya dito ay 1. And because of that, the value of h and k will always be the same kasi 45 degrees yung angle of inclination ng line na yan. Okay? So whether the circle is on this side, on quadrant 3, or on this side, quadrant 1, if we square h and k, yung negative niyang h at k dito sa baba ay magpa-positive pa rin. No? So whether your h, for example, for this circle, the center is here. So the value of h here has a negative sign and the value of y or k here has also a negative sign. But in our equation, we square both h and k. So whether the circle is here or there, once we square it, we would still get the same result. Okay? And we can apply or impose the relationship between h and k that they are always equal. Whether the circle is here or there, h and k are always equal because the angle of inclination is 45 degrees. So h is equal to k. Therefore, this equation will be h squared plus, let h be equal to k. So h squared na rin yan equals r squared. And from this, I can now have 2h squared equals r squared. Okay, so we now have a new equation. No? So we can now replace this r squared with 2h squared. And we can replace this k here with simply h because k is equal to h. Okay? So we now have x minus h squared plus y minus this k will be replaced by h once again because h is equal to k. Squared is equal to this r squared. I can replace it with 2h squared. Okay, so by imposing all the conditions stated in the problem, we are now able to reduce our equation into this. No? And this equation contains only one arbitrary constant h. Kanina tatlo sila, ngayon isa na lang. So, mas madali na nating masosolve yung problem ngayon. Because we only have one arbitrary constant. So kung isa lang ang arbitrary constant, isang differentiation lang ang kailangan nating gawin. Sir, magdi-differentiate na ba tayo agad? Hindi pa. I-expand mo muna iyan. Ano? Tapos, i-simplify natin. Okay? So, let us expand. Gawin nating x squared minus 2xh plus h squared plus y squared minus, here we have 2yh, and then plus h squared equals 2h squared. Of course, this equation looks lengthy, but of course we can simplify the equation. Here we have h squared, and here we have another h squared. And on the other side, we have 2h squared. So definitely, the terms will cancel. Mawala na ito, mawala na rin siya, at mawala na rin ito. Now, ang gawin natin is pagsamahin natin ang mga terms na may arbitrary constant na h. So first, ito munang x squared. X squared plus y squared. Okay, so we have a common factor, negative 2h. Negative 2h. Kaya, siya yung common factor mo. At ang matitira, of course, yung multiplier dito na x, at saka ito, ang multiplier niya ay y. Sir, bakit plus? Kasi po, minus na to. Okay? Ayun o, minus 2hy. And then, minus 2hx. Ito silang dalawa. Equals 0. Okay? So, we are now able to simplify this lengthy expression. Now, we can isolate the term containing the arbitrary constant. Kapag ka itong part na ito inilipat ko sa kabila at i-divide ko both ng x plus y, maa-isolate natin yung h. Okay, so let me rewrite this equation on the next slide with 2h isolated. So we have 2h equals x squared plus y squared over x plus y. The next step is now to differentiate. So we can eliminate the arbitrary constant h. So if I get the derivative of this, of course, I will get 0. So ito naman, gamitan natin ang derivative of a quotient. So we have here, ito yung iyong u, at ito naman ang iyong v. Di ba kapag nagdi-differentiate ka niyan, v du minus u dv over v squared. Okay? So gawin ko na lang siya yung nasa left side. So we have v, x plus y, and then the derivative of the numerator, we have 2x plus 2y, y prime, minus the numerator, x squared plus y squared, times the derivative of the denominator, we have 1 plus the derivative of y with respect to x, y prime. And here, we differentiate this because this is an arbitrary constant. Its derivative will be 0. Okay? So again, this equation looks quite lengthy. So what can we do? We can simplify by combining like terms. Okay? So what are the like terms that we need to combine? Combine all the terms containing the derivative. Okay? So ito yung may derivative. Yan. So lahat ng terms na may derivative, i-factor ko. Ang common factor yung derivative. So first, we have 2y na imumultiply mo sa x plus y. So we have 2y na imumultiply mo sa x plus y. And then, so kailangan ko pala itong lagyan ng, ayan, y prime. Okay, kasi may isa pang term dito na mayroon ding y prime. Tapos ang sign niya ay minus. So dito, minus. Ano yung term na may y prime dito? Here, y prime will be multiplied with x squared plus y squared. Okay, so ito na ngayon. Ang lahat ng terms na may multiplier na y prime. So ngayon, ano naman yung mga terms na walang y prime? Itong dalawa, x plus y, imumultiply ko sa 2x. So plus x plus y multiplied by 2x. And then minus, ito naman, x squared plus y squared, imumultiply ko sa 1. So, minus x squared plus y squared. So, can I simplify this? Yes. Simplify natin yan. Y prime times, ito magiging 2xy plus 2y squared. 2xy plus 2y squared minus x squared minus y squared. And then plus, itong lahat ng to, simplify natin. We have 2x squared plus 2xy minus x squared minus y squared equals 0. Sorry, nakalimutan kong lagyan ng 0 kanina. So we simplify this further. Y prime times here. What will be left is 2y squared minus y squared. So we will be left with a single y squared. And then here plus 2xy and then minus x squared. And then plus this term which does not have a multiplier of y prime. 2x squared minus x squared is just a single x squared. And then plus 2xy minus y squared equals 0. May kulang. Guys, I forgot to include yung derivative niya. Nakalimutan kong ilagay dito. Sorry. Nakalimutan kong ilagay dito yung x plus y squared. And then after that, mai-eliminate din siya kasi I can multiply both sides of the equation by x plus y squared. So magka-cancel to. Kapag ito naman, minultiply mo ng x plus y squared, 0 pa rin ang sagot. So kapag sinimplify mo, ganito pa rin yung makukuha nating expression. Now, this could be your final answer. Hindi na ba natin masisimplify yan, sir? Actually, hindi na. Kasi, ito, pwede mo sanang gawing special, isimplify to. Kaso nga lang minus to eh. So, hindi mo siya magagawang x plus y squared. Kasi yung x plus y squared, that is x squared plus 2xy plus y squared. Or, sabihin mo x minus y squared. Dapat yan ay x squared minus 2xy plus y squared. But here, yung square term natin sa dulo minus. Ito laging plus. Okay? So, hindi pwede. So, this is our final answer now. We can also express it in differential form by multiplying both sides of the equation by dx. So, pag minultiply mo yan ng dx, magkabila, ang matitira dito, y squared plus 2xy minus x squared dy plus x squared plus 2xy minus y squared dx equals 0. So, again, this could be your final answer if it's in derivative form, or this could be your final answer if it's in differential form. So, medyo mahaba ng konti, ano? So, ingat tayo sa algebra natin. Baka yung mga factoring natin, magkamali tayo ng sign, magkakamali rin tayo ng final answer. So, you have to be very careful and cautious when you are performing manipulation of your solution. So, let us solve the last and final problem for this episode. Here, we have a family of sine waves this time. Find the differential equation of all sine waves with a period of 2 pi and a phase shift of 0 degrees. Ano bang itsura ng mga sine wave na yan? Ito oh. So, what is the equation that describes the family of sine waves? So, in general, a family of sine waves can be written as y equals a times the sine of 2 pi over the period of the sine wave represented by t and then minus theta. Okay, here a is called the amplitude. Lagay natin dito ha, a. That's the amplitude of the sine wave or its peak value. Here the amplitude is this. Here the amplitude is there. Okay, nagbabago siya ng height or amplitude. T is the period. And theta is our phase shift. Okay. But it is said in the problem that the period must be 2 pi. Okay. So, if I make t equal to 2 pi, 2 pi over 2 pi, actually, we should have a variable x there. So, if our horizontal axis is x, it should be x. If our horizontal axis is t or time, it should be t. So, but for this purpose, let us use x. So, 2 pi over t times the variable x minus theta. Okay. So, according to the problem, the period represents the time required to complete one cycle. Okay? So that is why one cycle from here to there is 2 pi. So this is 2, 4, 6. Di ba ang 2 pi is 6 point something? So ito yung 2 pi mo. Here, we have pi. Yan. So, ang period ng mga sine wave na yan ay 2 pi. So, 2 pi over 2 pi ang matitira lang ay x. Tapos, ang phase shift niya ay 0. So, kapag sinabi natin na phase shift, saan ba nagsisimula ang sine wave mo? Okay. So, if your sine wave started here, okay, so this is your phase shift. Okay? Phi or theta. Minus yan kasi na-delay siya. Kapag dito ka naman nagsimula ang sine wave mo, ito yung phase shift mo. Positive siya ngayon kasi nag-advance siya. But in the problem, the phase shift is 0. That is why lahat ng sine wave, kung inyong makikita, doon nagsimula sa origin. Okay? So, i-delete ko na itong mga ito. Ayan. So, 0 ang phase shift, kaya dito sila nag-start. Okay? So, 0 na to. Kaya ang matitira na lang sa ating equation is y equals a times the sine of x. So, na-simplify natin, no? By imposing the conditions mentioned in the problem, we are able to reduce the equation into one having only a single arbitrary constant a. Alin lang dito ang nagbabago na arbitrary? Yung amplitude ng mga sine wave. Okay, di ba kanina sa circle ang nagbabago, radius. Doon sa line ang nagbabago, slope. Dito naman, ang arbitrary na nagbabago ay yung amplitude. Okay, so ano kaya ang differential equation na nagde-describe dito? Of course, to get the differential equation, we need to differentiate, of course, with respect to x to eliminate the arbitrary constant a. Okay, so mag-differentiate tayo. Y prime equals, the derivative of sine is cosine, so we have a cosine x. And how are we going to eliminate a? Okay. So, kagaya ng ginawa natin kanina, we can use substitution. Ano? So, mula dito, sa equation na ito, ang a natin ay equal sa y over sine x. Ano yung sine x? Yan ay lumulubog. Why? Because it sinks. Parang barkong butas. Lumulubog. It sinks. Ay, shit. Sorry, hindi na ako magjo-joke. Baka hindi funny para sa inyo. O, sige. Now, I can replace this a with this expression. So, now I get y prime equals a, which is now y over the sinking sinks multiplied by cosine of x. So, this is now our differential equation, which does not have any arbitrary constant. So, sir, is this the final answer? Can you simplify that? Actually, we can. How? Because cosine divided by sine is the reciprocal of tangent, and that is cotangent. So, I can write this differential equation in this form. Y prime equals y cotangent x. So, this is now my differential equation. Or I can equate that to 0. Y prime minus y cotangent of x equals 0. O, diba? Napakadali. Sobrang dali. So, let us have a recap of this topic. If we are given a family of curves, we can formulate a function or relation that describes that family of curves. And that function represents the general solution of the differential equation that we are looking for. Kagaya dito. Ito yung general solution ng differential equation na ating hinahanap. After that, we formulate the differential equation by taking the derivative. And since we have only one arbitrary constant, we differentiate once. So, if you have already your function, try to simplify your function as much as possible with the least number of arbitrary constant. Kanina, ilan ang arbitrary constant natin? Isa, dalawa. Pero nung ini-apply natin yung condition na sinasabi sa problem, nagawa natin ang paraan na maging isa na lang ang arbitrary constant mo. And then nag-differentiate ka once. Nung makapag-differentiate ka, eliminate the arbitrary constant using substitution or elimination method. And finally, ang makukuha mo na is yung differential equation na walang arbitrary constant. No? And once again, this differential equation describes all these sine waves whose period is 2 pi and whose phase shift is 0. So, di ba madali lang? Okay. So, that concludes Module 1. Next week, we will start with Module 2. So, Module 2 is all about solution of first order differential equations. Okay? So, hanggang dito na lang muna. See you again in my next video. Bye!